Hello dear student, I welcome you all in my class. Today we will discuss the basics of flight mechanics and control. In the basics of aerodynamics lecture, we got an idea about what is lift, half rho v square s into Cl, and drag, half rho v square s into Cd, where rho is a density at a particular altitude where you are flying, v is a flight velocity, s is a wing area, later we will size this, and Cl is a lift coefficient. Here Cd is a drag coefficient coming from both due to shape and due to lift. So now if these forces you have, and in basic propulsion we got to know the idea about thrust. Okay, so now you can use these three forces to make your flight better. For example, if you are flying at a steady state level flight, your lift will be equal to weight and your thrust will be drag. Now if you remove this lift, let's say this is put 0, so what will happen? You will fall like a stone, the aircraft will fall like a stone. So what is the importance of this lift in flight mechanics? We can discuss with by considering simple point mass model. Let's say you have a stone in your hand, if you throw, it will follow like this parabolic trajectory. Consider this any point A where your weight is acting downward and velocity is v, and opposite to this there is a drag. Okay, what angle you are making with the horizontal is gamma. Okay, so if you resolve these forces, you can make get mg cos gamma, and in this direction mg sin gamma. So if you balance this equation, you can write m dv by dt, external force, rate of change of momentum equal to external force, which is d plus mg sin gamma. You consider this is a positive direction and this is a negative direction. Okay, similarly second equation you can write mv square by r is minus mg cos gamma. So at a point we have written two equations, one is translation and one is rotation. Now we are interested in the second equation, because second equation, from second equation you are turning, right? You are first ascending and then falling, like falling. Okay, so take second equation, mv square by r minus mg cos gamma. Gamma is a flight path angle. You can write v by r into v and minus mg cos gamma. You can write m gamma dot minus mg cos gamma, you divide by m, you can write minus gamma dot equal to minus g cos gamma by v. This you can write. So from this equation will tell how you are turning, what your turn rate. Now consider your flight, a steady state level flight. If you are flying at a steady state level flight, your gamma is 0. So somehow you have to make gamma equal to 0, right? But how can you do this? Let's see. If you add lift in this direction perpendicular to this speed and drag, you can change this equation to this equation. So because of lift, you can change the equation to mv square by r minus g cos mg cos gamma plus lift. So again I will write here mv square by r equal to minus mg cos gamma plus lift. Now again divide by m and v by r, you can write gamma dot v minus mg cos gamma plus lift, you divide by m v, you will write gamma dot equal to minus g cos gamma by v plus L by mb. And this equation will remain the same, equation 1, because your lift is directly perpendicular to the speed. Now consider this flight scenario, you want to make flight path angle 0, so write gamma equal to 0. So if you put gamma equal to 0, you can write gamma dot equal to 0 also, and then you can write minus g cos gamma gamma 0, then cos 0 will be 1 g by v plus lift by mv, and then you can write L equal to mg, and mg is weight, so you can write lift equal to weight. So that is how the lift equal to weight comes when you fly at a steady state left side, when you consider this model. So see the beauty of the lift, why the lift is important. If you do not use lift in a proper way, you will not be able to fly. So that is the importance of lift in a flight mechanics and control. Okay. So how beautifully you are using lift and how beautifully you are using drag. Okay. How you are balancing the weight, that comes under the flight mechanics and control part. Okay. And sometimes, for example, like you need a drag to stop the motion of the aircraft, and sometimes you do not want a drag. For example, if you want to fly at a steady state level flight, we want less drag, but when during landing we want more drag to cover the shorter runway. So it is important to know that you should utilize these forces in a very effective manner to get the optimal flight performance, optimal control also, and a very good stability characteristics from the our designed aircraft. So in basics flight mechanics and control, we generally study the force and moments acting on the aircraft, and essential for aircraft design, stability and control, as already said. So you can see the basic component of the aircraft here. So this part is known as a cockpit part. This is a fuselage body. From this point to this point, all body. This is a one side of the wing, and this is another side of the wing. This is engine. Okay. This is horizontal stabilizer. This is vertical stabilizer, and associated with this small surfaces called elevator, and this is also elevator. And similarly for a vertical stabilizer, this is rudder, and this is flaps, this is aileron, this is spoiler. So I will tell you how the individual will function. Okay. For example, this engine will provide you the thrust, wing will generate the lift, horizontal tail will provide you the longitudinal stability, vertical tail will provide you the lateral and directional stability. We will discuss in when we will cover the aircraft stability and control part of this course. And you can see there are the three primary controls associated with this aircraft. One is aileron, and then elevator, and then rudder. So job of the aileron is to roll the aircraft for left and right direction. For example, if you deflect the aileron, you will have a more lift at the downward deflected aileron and less lift at this wing. When you deflect the aileron down here, you will have more lift, and if you deflect the aileron up, you will have a less lift and you will roll that side, because here you are changing the increasing the camber, here you are decreasing the camber. That is the job of aileron, to provide the roll control. Flap is a high lift device, is called secondary control surface, where you need more lift, for example at the time of takeoff and the time of landing. Then you may use flap. It is always deflected downward to increase the camber for getting the CL max. Slats, it's another high lift device. It also increases the CL max, but it will also improve the flow over a wing. It will try to attach the flow over a wing. Fuselage body, this will carry the passenger, this can carry the payload, this can carry the pilot, okay. And this elevator will provide you the pitch control. When you deflect the elevator up, plane will go up, and if you deflect the elevator down, it will go down. Similarly at the rudder, when you deflect the rudder in this direction, aircraft will try to yaw in this direction, and when you deflect the rudder in this direction, it will go in this direction. So this rudder will provide you the directional control, elevator will provide you the longitudinal control, and aileron will provide you the lateral control. In detailing we will discuss in the aircraft stability and control part of this course. Okay, what the things is remaining? One is spoiler. Spoiler is used to, the name itself implies you are spoiling something, right? So here what you are spoiling? Basically you are spoiling the lift, okay? So if you spoil the lift, and here also if you put the vertical surface up, for example if you open like this, you will create a lot of drag also. So in the type of landing, the spoiler is used to spoil the lift and to make sufficient drag to increase the CD to make the landing distance shorter. If you deflect the spoiler, your ground roll distance will reduce. And also spoiler can be used to generate the drag to control the sometimes yaw also. I will tell you some more detailing, like apart from the basic control of rudder and elevator and aileron, there is another job to do. For example, rudder will use an asymmetric power condition. Rudder can be used in spin recovery. Rudder can be used in the cross wing landing case, and aileron can be used for a yaw also. Differential elevator can be used to roll the aircraft also. So these things detailing we will cover in the aircraft stability and control part. And we have to, since we are talking about the forces and movement, then we have to understand the forces and moment direction here. Now as I said, lift equal to weight and thrust equal to dead. If lift is greater than weight, the plane will rise. If the weight is greater than lift, plane will fall. If the drag is greater than thrust, plane will slow down, and if the thrust is greater than, plane will accelerate. Okay, I explained. Now you can understand the axis system of the aircraft. For example, like take a finger, your hand like this. So whatever this finger is pointing is x axis, positive x axis, and this finger is positive y axis, and the thumb pointing downward is a positive y axis. So okay, so when you take this hand like this, so your thumb is pointing at a positive x axis. This is nothing but the positive roll. Positive roll you can achieve like this. Okay, similarly for a pitching, this is a positive y, so we'll take hand like this. This is a thumb pointing in a positive y, so this is positive pitch. Okay, similarly if you do the yaw like this, your thumb is pointing downward, positive z, so this motion is a positive yaw. Okay, so this roll positive, this negative roll, this pitch is positive, this is negative pitch, this yaw is positive, this yaw is negative. Okay, So all the movement is you are calculating about the center of gravity. And as I say that equilibrium flight means you don't have any net force to accelerate and not net moment to rotate the aircraft. So you are in equilibrium flight. So in order to see how the aircraft is behaving, you have to know the what type of aircraft instrument is there in order to monitor the flight. So there are the 6 basic instruments is here. One is airspeed, and this is artificial horizon, and this is the altimeter, and this one is a turn coordinator, and this is a heading indicator, and this is a vertical speed indicator. So consider this first one, airspeed. So airspeed works on the principle of pitot tube. For example, here you can see if you have a total pressure P naught and static pressure Ps, so you can write P naught equal to Ps plus half rho V square, and then V you can write 2 into P naught minus Ps divided by rho and then under root. Okay. So based on, if you measure the total pressure and static pressure, if you know the sea level density, you can find out what the indicated speed is. Yeah. So this is how this instruments on work based on that static and stagnation pressure. Stagnation pressure, the flow is coming, and if you bring this flow to stop isentropically, then this pressure will cause the stagnation pressure. And if the air is moving and you have a hole, let's say for example somewhere in from that hole, if you are sensing some pressure moving air, if you are sensing the pressure of the moving air, that is nothing but the static pressure, and half rho v square is a dynamic pressure. Now this second instrument is artificial horizon. This work on the principle of gyroscope, where you can see the spinning disc. This is called rotor. Gyroscopic works on the principle of rigidity and precision. So rigidity means when you rotate this rotor at a very high speed, even if you deflect this gimbal, this remains the horizontal position only, as it is horizontal, right? So when the aircraft will pitch or aircraft will roll, this will remain stationary. Okay, so with this you can actually measure the roll angle and pitch angle. And this is the uh, altimeter, which is also work for the static pressure case. For example, at a different altitude, you are having a different static pressure, and corresponding to that, it will show the what altitude you are flying. And this is a turn coordinator. Basically, it will show whether your turn is coordinated or not. For example, if you later I will tell you in a, when you bang the aircraft, you will start side slipping, right? So this ball, this is black ball, will may go left and right direction. Okay, so you, in order to make a coordinated turn, if you deflect the roll in this direction, you will start side slipping. So you do not want to the side slip, that then you have to deflect the rudder in this direction to counter the yaw. So that means you will take a coordinated turn without any side slipping. So this ball will remain at the center. So this is also work on the principle of gyroscope. Okay, this is a heading indicator. It from the magnetic compass, you can actually measure at what heading you are flying. For example, north is considered to be as a 0. Okay, and from this you can actually have an idea about where you are flying to the east or south or west. And this is a 360-degree scale, and this one is a vertical speed indicator. It will work based on the principle how fast the static pressure is changing. Okay, so that will tell you how at what rate the altitude is changing basically. Okay, so these are the 6 basic instruments is required to monitor the flight performance. Okay, so in this class we have covered the basics flight mechanics and control, but detailed study we will do in the flight performance and flight stability and control part of this course. So thank you very much.